All right, so this is going to be Unit 1 review for your test, or if you missed something, and this will help you out. All right. So precision and accuracy was the first couple things we talked about. Accuracy refers to how close a measurement is to the standard or true value, so your correct answer, versus precision refers how close two or more measurements are to each other, regardless if those measurements are accurate or not. So normally I like to show this with targets or with numbers. So remember, accuracy is about decimal places. So like if I had 0.3320, that's accuracy, a lot of decimal places. Well, precision is if I measured something like 0.3, then I said 0.35, and then 0.31. They're all pretty close to each other, okay? So then, like if I can look at targets as well, if I said which one of these represents precision, you would say this middle target right here. You would say that's precision. Well, if I said which one says accuracy, you'd actually say, oh, wait, this one's also precision, and it's accurate because it shows the bullseye, because that's the goal, is to hit the bullseye. While the first target, you would say neither one. It's neither accurate or precise because nothing's really hitting that bullseye, and they're all spread out, and precision's not about spreading out. Then we talked about how to count significant figures. So there's 3 rules. 1 rule. First rule, any number 1 through 9 is a significant figure. So like if I have a number 3,456, I would say that's 4 significant figures because there's no zeros or anything like that. My second rule is the sandwich rule. So any trapped or captured zeros are now significant. So like how in 101, the 0 is in between 2 ones, so there's 3 significant figures. On the second example, only the 2 middle zeros are significant, while these last 2 are not. So those are not significant, so that's why it's 6, because they're not trapped or anything. Okay? And then the last rule is the decimal point rule, and it's any number with a decimal point. Remember, we read these numbers left to right, and when you hit a 1 through a 9, then everything counts after as a significant figure. So that's why if you look at my examples, I don't hit a number that's not a 0 until it's 9, so everything counts. That's why it's 3. While this number, I already hit the 2, so everything counted, and it's 3 again. And then this number, I don't hit a significant number until the 6, so that's why it's 3. Okay? That would be the decimal point rule. So remember the actions I taught you in class, that count with your fingers, sandwich, decimal point rule. The decimal points rule is always reading left to right. So here's some practice. And on this practice, I'm just going to show the answers. This is one of those you should pause. Can you guess it? Then press play. That's what I always say for these practices. Don't just watch for the answers. Pause it and see, do you know the answer? And go. So like this number, 5 sig figs, and I'll underline which ones are significant. This one is 4 sig figs. And notice I'm not pausing, so you must pause. This one is 5 significant figures. Those are the numbers that are significant. This example, it's only the ones in the beginning, okay? Because remember, we can rewrite this using scientific notation. How about this example? It is 2 significant figures. And then this one is also 2 significant figures. And those are the 2 numbers. All right, I hope you did well. Now math operations. Remember, there's a difference between multiplication and division, and then when you add or subtract. So multiplication and division, you need to look at the numbers that are given, like 6.38 times 2.0. And the rule is your calculation, whatever it says, you have to round it based on the least significant figures. So you have to count how many sig figs are in each number. Like this one's 3 sig figs, while 2.0 is 2 significant figures. So my answer, even though this is my calculator, I have to have only 2 significant figures. So I only want these first two. So I'm canceling out the 7 and the 6. And since the first one I canceled was a 7, I have to round the number up to 13. So that's why the correct answer is 13, because I must round it to two significant figures. It's always about rounding, okay? This is the one that I have practice on that I would definitely pause on. So like my calculation, here's that one. This is what my calculator says. And then figure out what it's going to be, because this is when I pause and answer. So once I put the calculator, pause the video, and then see if you can figure out the answer. All right, I'm just going to click through the rest of these. The only thing I wanted to say about this one is if you have any questions on why these are the answers, please make sure you message me on Google Classroom, okay? I will message you back of why and how, and I'll even make you your own personal video if I need to, okay? Next one. Addition and subtraction, it's all about decimal places, not significant figures. It's about decimal places. So all I do is count how many numbers are after the decimal. So like in this example, I look and I'm like, okay, that's 1 after the decimal place. Well, this has 3. So I only want 1 number after the decimal because that's the least. So if I look at this, I'm like, all right, I only want 1 number after the decimal. So I'm crossing off a 3, so no rounding needed, and it's just 18.7. Notice that this was like multiplication division. I wouldn't say 18.7 because 6.8 only has 2 sig figs. That's why it's not about significant figures anymore. It's about decimal places, just counting how many numbers are after the decimal place. So let's look at some practice for that one. So I'm going to show the calculation like I did before, what the calculator says, and then you figure out what the answer should be. And this is when you should pause anytime I put calculator says. Okay, once again, please make sure you message me. And notice this last example, even though my calculator only had 2 decimal places, my question and my calculation, they all had 3 decimal places. So even my answer is supposed to have 3 decimal places. You have to at least match. You can't go lower, okay? All right, scientific notation. This was the last thing I taught. Remember, it's just putting it as m times 10 to the nth power. If you see a positive n, that's for a really, really, really big numbers. Well, negative n is just a small number. It's not a negative number. It's just a really, really, really small number, small decimal point number. All right, so here's my example of how to do it. So let's say we have this giant number right here. The first thing is insert an understood decimal point. Because it doesn't have a decimal point and we don't want to change the number, we're going to put it at the very end. And then, step 2, decide where the decimal must end up. So 1 number is to the left. So that would be between the 2 and the 5. So now only the 2 is going to be to the left of that decimal point. Then I'm going to count how many places I bounce this decimal point. Because remember, decimal points bounce, not fly. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9. So I bounced 9 times. Now I'm going to rewrite it in this format. So the m should now be 2.5, times 10, and the n is how many times you bounce it. So let's look. It should be 2.5 times 10 to the 9th power. And remember, if I want to take it out of decimal point, I will take that point and move it to the right for large numbers. And if I want to put standard notation for negative ends, I would make it to the left for small numbers. And remember, that exponent is how many times it's moved, not how many zeros there are. So small number, same thing, but we don't have to do the putting a decimal point because there already is one. So now we just want to make it 1 to the left, so 5.79, and then we count how many places. 1, 2, 3, 4, 5. So now we rewrite it. But because it's a small number, we're going to make a negative n. So it's 5.79 times 10 to the negative 5, since it was a really small number, if it's less than 1. Okay? And then remember, taking it out, it's just like if I had to take this one out, I would say 5.79, and if it's negative, it goes to the left. If it's positive, it goes to the right. 1, 2, 3, 4, 5. And that's what the original number looked like, but with better handwriting, right? If you accidentally go the other way, just always remember negative means small. So if I accidentally go to the right, I would go, oh, that's a really, really big number. I didn't want that. So just go the other direction, okay? Measurement lab. So we just had a lab that's about measuring. So there's some things that might be on the test that you'll need to know. Like looking at a graduated cylinder. I must know what this is. This is called the meniscus, this little bubble that forms, like half of a bubble. It goes down because of gravity. So the thing that you need to remember, we always read from the bottom of the curve or the meniscus. In this example, since this is 10, 11, 12, 13, 14, that's where the bottom of the bubble is on 14. So that's why this would be 14 milliliters, while the top of the bubble is 15. It doesn't matter. It's always the bottom of the bubble or bottom of the meniscus. Okay? Bottom of the bubble. Always remember it's the bottom. The bottom of the bottom of the bottom. So let's look at my example. This example. How much milliliters do you think is in here? Pause if you want to figure it out on your own, which you should. Okay? So I go, this is 3 and this is 4, and there's 5 lines, so each line's going up 0.2. So 3.2, 4.2, it's right in between, so 3.4, maybe 3.45, because we always want to be accurate in our results. And I'm going to tell you the one on the test is easier than this one. It's going to be the standard one that you saw that each line means 1 milliliter. Okay? I'm not going to make it as difficult as this one. Next one, for measurement, just measuring distances. So put it on the ruler and just make sure you look at these little lines, right? The little lines. So like the paper clip, I would say 3.2 because it's on the second line right here. So 3.2, while the key is right on 5. So that's why I say 5.00, because this last one should always be an estimate. That's why even with 3.2, do I know if it is exactly on the 2? I don't know, because there's not other little lines. So that's why it's a guesstimate or an estimate that I saying it's exactly on the 2, so that's why it's 3.20. Accuracy is key. So what do you think is the length of this pencil right here? Make a line going down to the 16. Is it all the way to the 16 or is it a little short? Oh, it's a little short. So which one would it be? Hey, that is correct. Good job. I don't know who I'm talking to, but I'm talking to you now. I told you I'm a dork. Measurement, last thing. masses. So if you look at a mass, and there will be thermometers as well, but they're just like graduated cylinders. Okay, just like doing that. But I wanted to review this because I saw even on the lab people are having problems. Remember, look at the weights and you have to add them up. So it's 142. So that's why it's 142, because I have to add them up. Make sure to see where those arrows are for each thing, because I'm going to put an image kind of like this one, and you have to make sure you see if these are zeros or not, okay? So like, let's do one practice. Looking at this one, what do you think the mass of this object is? So 500 can't be A, can't be D. 40, I'm already gonna say it's probably B, huh? But just make sure. 145, but then it goes two places. So 145.2. So we definitely know it's B. But notice I can take off options just because of the small amount I knew. And I already knew what the answer was without making sure, is this 0.2, is it 0.02, or whatever. See? Use multiple choice for your advantage for this test, or when you're working on things. So that is the end. I know that was quick, but I hope that helped you out. You will do amazing. So good luck, study hard, and if you need to take that quiz again or anything like that, you are amazing. Yay!